Hello class, we're team number 15, the mechanical design project number 1. Our project is clutch design. Team members are Javier Gutierrez, Valeria Proano, and myself, Joseph Ruocco. Right now, Javier is going to talk to you a little about the history, about clutches, and the background.
Clutch is a mechanism that is used to transfer rotational motion from one shaft to the other. This mechanism can be engaged or disengaged to allow the shafts to rotate freely or at the same speed. Here's a diagram of when a normal disc clutch is engaged and disengaged. When the clutch is engaged, the rotational motion from the input shaft is transferred by frictional forces towards the output shaft. However, when the clutch is disengaged, both shafts detach from each other, allowing them to spin at different rates. Here is an exploded view of the typical automotive clutch. As you can see here, the clutch connects the transmission to the flywheel that is connected to the engine. When in clutch design, we have to take into account different design factors. One of them is energy loss. As one shaft attempts to reach the same speed as the driver's shaft, kinetic energy appears in the form of heat. This heat is corrosive to the system because it can damage the clutch and the surrounding mechanisms. Another factor is the actuating force and also the torque transmitted. By analyzing the pressure points and doing a static analysis on the clutch, the forces and the torque and support reactions can be determined. Now, Valeria is going to talk about the different types of clutches.
There are many types of clutches in the market today. They're all based around the same principle of friction. What varies from design to design is the method by which these surfaces come in contact to create the desired friction. Some type of clutches are rim clutches, band-type clutches, disc axial clutches, and cone clutches. Rim clutches are composed of a shell that is attached to an output shaft and shoes which are mounted to the input shaft. Here's the output shaft will be connected to this rim, and the input shaft will connect it to the shoes. There are three elements of these rim clutches: the frictional surface, the actuating mechanism, and the mean of transferring torque from and to. There are two types of rim clutches: internal expanding and external contracting shoes. There are three types of mechanisms I'm going to talk about for rim clutches. The centrifugal clutch works with fly weights with frictional surfaces that come in contact when the input shaft is rotating, and a centrifugal force expands these flyweights to come in contact with the outer shell. A magnetic clutch creates a magnetic field in the outer shell, which attracts an armature to a rotor and then engages to the outer shell to transfer the torque. Finally, the hydraulic and pneumatic devices are the ones that use compressed air or different fluids to have the contact of the shoes with the outer shell. Band-type clutches work with bands wrapped around the drum that rotates, and due to friction with the bands and the drum, torque is transmitted. These type of clutches are often used in machinery for low-speed applications. Disc axial clutches will be later talked by Joseph, explaining the actual design. They are pretty much how the way they work is you have the frictional contact is in the axial direction parallel to the two shafts that are being rotated. Cone clutches work with a cone connected to an output shaft that actually slides into the cup, which is connected to the input shaft. As you can see in the picture, this is the cone, and this is the cup. They're mated by a spring and actuated with a fork.
frictional contact clutch design, or actual clutches. These type of clutches are composed of a driven shaft, a disc plate, a frictional plate. And basically what they do is that when the disc plate hits the frictional plates have friction pads. These pads, when in contact with the actual disc, will produce friction. During this process, there's what we call slippage, because the two main surfaces are rotating at different speeds. When this contact is produced, a lot of energy is loosed through heat. Clutches are designed to sustain these extreme heat conditions generated at that moment of contact. In the figure shown in the slide, it's a single plate clutch, meaning that it only has one disc and one frictional plate. More complex forms of friction clutches consist of multiple discs and friction plates. To improve cooling and reduce wear, some clutches use fluids. These fluids, what they're going to do is they're going to help the clutch dissipate the heat. These are called wet clutches. Okay, actuating force. Actuating or axial force is the one responsible to maintain a uniform pressure conditions. These forces will determine the amount of torque and the pressure that the system is going to sustain. The assumption of a uniform pressure is not totally accurate, because when you have that contact, this pressure is not going to be uniformly distributed across the whole plate. Usually, pressure is going to be greater where the diameter is smaller. To perform the calculations for a clutch design, two different methods are used: uniform wear and uniform pressure. Uniform wear. This takes place after some initial wear has already been done to the actual pads, to the actual disc, I'm sorry. The wear is proportional to the pressure and the velocity. Yielding, and then the formula used is this formula right here, where K includes all the material properties, and F1 and F2 are only modifying factors that will apply to load, speed, temperatures, and cleaning conditions. The actuating force can be found by using this following relationship right here, which actually involves the outer diameter, the inner diameter, and the maximum pressure that it can sustain. To find the value of the total torque produced by this actuating force, you substitute this into a more general equation, and then it satisfies to this more simplified version of the torque. Uniform pressure. Okay. When a friction clutch is said to be subject to a uniform pressure, it says that at every single point of the disc, the maximum design pressure is going to be acting on that surface that's going to be undergoing friction. To obtain that actuating force, you simply do the product of the difference in diameters. So you use this formula. The total torque capacity can be found as was done before on the uniform wear equations. It just has a little variations. These terms here should be all cubed and squared. And that's basically how the clutch design mechanism would work for a friction clutch.